Hi and welcome to my talk on what's new for Java in the clouds. So this is a more general, maybe aspirational topic on what we saw for new things for Java in the last months and years, specifically on cloud computing and of course specifically with DevOps, with the topic that we have today. So hi, from my side, my name is Sebstian Daschner. I work for this company called IBM, and I am a Java developer advocate, so I do a lot of things with Java and then also a lot of Java titles involved. And I'm very proud of being able to support the future of Java and help specifying the future of Java Enterprise in the JCP in the past and now in Jakarta EE in the future. And if you can see, a lot of other Java titles involved. So that said, let's talk about Java. And let's talk about the future of Java specifically. So what we have new things for upcoming and what we saw specifically this year. So who of you uses Java in a production system? Hands up. Okay, that's almost everybody, at least a lot of you. And yeah, this is also what we see. Where are we in enterprise software and in the cloud? So this is usually my focus. So we see a lot of Java in the industry, right? It's like #1 of the programming languages. It's widely used in enterprise software, specifically in Germany. And, well, we often teach it even in universities. So, for example, when I was studying, it was the main language. And I see this as well in many, many other universities. A lot of people know Java. We have 20 plus years of experience. It's been out there for a while. And it's still, well, widely used and more. So this is, well, an interesting thing, an interesting experience. And what's interesting, we can run Java from the smallest and tiniest runtimes to the largest one. Your car probably runs Java, your DVD player, if you still have such a thing, runs Java, your phone likely runs Java if you have Android. Huge enterprise applications and clouds, of course, run Java. It's, well, anywhere. So what about the future? Or what about this year and how the future might look for a Java in the clouds? So, well, how do you think about the future? Do you think positively about the future? Or are you still somewhat struggling from all the new things that are there, from maybe Java 8 with Lambdas and what we got new there? Are you already using a somewhat newer version that followed the new release cadence, like Java 9, 10, 11? Who of you runs Java 11 in production? Hands up. Who of you runs Java 10? Hands up. Oh, yeah, almost nobody. Did someone ever use Java 10? Oh, well, at least. Who runs Java 9? Okay, now everybody. Who runs Java 8? Okay, that's good, that's good. And a previous version, so not even 8? Okay, I feel you. So, yeah, we have a lot of versions to choose from, and that, of course, also creates some challenges. And then we might think about, yeah, how do we tackle that, right? Like in enterprises, this might not come easy. So do we think about that in a positive way, or are we more like, oh, that can be dangerous, let's see if there are other options? A lot of enterprises think that way, so that's something to keep in mind. So, are we trying to understand the new feature release process? Didn't even get like, when do we get some more Java versions? They seem to increase quite fast, quite quickly, right? In the past we had like 5 and then 6, and that was there forever, and then 7, that was there forever, and then 8, well, that was definitely there forever, and now it's 9, 10, 11, and yeah, we can't even keep up. And of course, or not of course, but a lot of people are worried about Java being able to use Java for free. There has been quite some, well, news around that topic this year, so we're going to talk about that a little bit as well. Or are you worried about the modules, Java 9? Who of you uses Java 9 modules, at least in some way? Oh, yeah, that's also what I thought. Have you tried out JShell or JLink? A few new things like that. So in general, there's a lot of going on in the ecosystem, specifically compared to the last years, right? And a lot of things that might, I don't want to say worry enterprises, but I can understand that a lot of companies look into this ecosystem and say, oh boy, what's going on there? And how can we tackle that in the future? Is that a thing to be worried about? So let's focus on these things now, because it's real and concrete, and specifically focus on all the updates that we see and all the new things with all the this release cadence upgrades. Let's try to understand the concepts of support, the new support options, and what that means, so then we know what we're getting for enterprises. So let's talk about the release process. Again, we had Java 6, Java 7, Java 8, and now fast forward 9, 10, 11, 12, and so on and so forth until a huge number, right? That seems to increase, well, with a high cadence. So, of course, that seems to worry some enterprises, because in the past it was always quite an effort to upgrade projects to newer versions, right? We have Java 6, then with Java 7 there came a new lot of things. Automatic resource management, we had collections and these diamond operators and so on and so forth. A lot of things that we could use in a new way. We were migrating some projects. We had to think of our production workload, right? And all these changes that come with a new version. So from experience, it always took a while to upgrade a project to a new version. And now that we have versions coming in that quickly, well, are we now spending even more time to upgrade every half a year because we have to, and then we can spend less time developing features? Or, well, do we see that as a chance? So what our ecosystem in Java is doing is just repositioning itself for a faster pace. I mean, the world is moving faster every single day, and we have to adapt. That's just a fact. And the motivation behind the faster release cadence was just that we are able to ship newer versions faster. It doesn't mean that every new version is equal to the same, well, feature change that we have from, for example, 6 to 7, including all the effort to upgrade. It's more like we get newer versions more quickly, and that means we get security updates more quickly, and we get, well, new smaller features faster as well, right? So instead of waiting for a huge feature such as Jigsaw that might delay other upgrades for a longer time, we can actually now, well, get a new Java, a new Java version quicker and earlier, which then will not be stalled by a huge feature, right? So that just means a bigger feature, such as Jigsaw was in the past, will then just come later in a later release, but still we get all these security updates. So that is somewhat, well, a positive thing. So we get more predictable updates. So rather than, well, guessing when a new version will be around, like who knows about the 8 release date, and that might be delayed, right? Now we have a predictable model of when a new Java version will come out. So with a consistent cadence, right? Like half a year, 6 months, roughly. That's the idea. And it's also easier to migrate. I know most of you have not played around with 10 or 11, but actually with the Java, the new Java versions, and I can totally second that, it's easier to migrate to new versions, of course, because the diff is smaller. So actually, once you got past the big 9 release with all the modules, migrating to 10 and 11 and beyond is actually quite simple. So usually you don't see any errors or anything that you have to fix or adapt on your runtime level. You just use the new Java version, and there you go. Right. So that's also something that you have to keep in mind. And now from the Java team OpenJDK perspective, we're now able to innovate faster, right? We can actually do more things, ship things more quickly, and be able to, well, include new, even smaller features in Java. And this is also what we want, right? So if you think about it, it's more like continuous delivery. This is something you should be familiar with in this conference. Who uses a continuous delivery approach? Oh, come on. Few more, I hope everybody, for their projects. And this is somewhat quite similar. So now, not continuously, but more often we will get new updates. And in general, and we see that in many technologies, that our ecosystem is just repositioning itself for a faster pace. And the question I have, are you too? Because it doesn't help to say, oh, I stay on Java 8 forever, right? Or I stay even on Java 6 forever. And then you might pay to get some more upgrades, and if you pay enough money, then you will get upgrades probably forever. But is that a good model to say you stay on some version forever, or you want to upgrade, anyway? So that is something enterprises have to think of, and that is something we have to tackle, that we say we keep on the current pace. So our projects will use a decent Java version at least, and we'll get all the security updates, so we're able to, stay productive and use newer features as they come along. And it doesn't help to just say, oh, we're not able to keep up with this fast pace, right? So just try to stay on top of things, and with continuous delivery approaches and with, a process that you can use in your project, you might be able to update to recent Java versions. Let's talk about another thing. The updated support model of Oracle JDK support. And the big question that the ecosystem had, is Java still free? So who of you had discussions in the projects where people were worried about Java is still free, and that where that might be an issue for your project? Yeah, that's what I thought. So, and there was a lot of FUD around whether this is the case, whether Java is now still not free anymore and will now die, of course, because all of that. And the tech press didn't really help for that. So there were actually a few poorly written articles that tried to jump on that hype train and say, we have problems here and there, and that might affect us, and so on and so forth. So about free software and a free Java, let's talk about the definition of free first, and what that means for us. So a lot of people use, free software, free as in beer, and want to use them freely as well, specifically for Java. So I don't know if you can share that information, but who of you uses a paid version of Java, including support? Hands up. Okay, at least two. The rest of you uses Java for free, right? Free as in beer. So that's the difference between these definitions. First of all, there's a free as in beer, in terms of you don't pay for things. And there's a free as in speech, in terms of you're free to use it, and you're free to adopt it. So the latter is, the idea behind open source software, typically, that you can just use it for free, you can adopt it wherever you like. And the first one is whether you're able to do that for free without paying. And there are many, many Java distributions there, and many companies and support models that are there. Of course, the most famous one is the Oracle JDK, and there is now also an Oracle Open JDK. Actually, the Open JDK is, I don't want to say the golden source, but that is the project where Java is actually developed, and most of the JDKs are based on that. There is a distribution from Adopt Open JDK, which is a nice community effort where multiple companies offer a workload and offer the possibility to get builds from an Open JDK that are built, for free, that you can use. There is Eclipse OpenJ9, that is a quite interesting JDK that I will show you later, and a few other ones from, for example, Azul and SAP. A lot of distributions to choose from. Typically, we're using Oracle JDK or OpenJDK, at least this was what I typically saw in the projects, to run Java. And now the question, is Java still free? Short answer, yes. So what happened, what did change? Well, we saw a change in the Oracle support model that from starting, I think, January next year, we will get free updates, like free as in beer updates for new Java models with the 6 model update cadence, right? And then if you use that further than that, if you want to use it longer, you would have to pay to get these updates from that distribution. But other than that, is Java still free? Are you free to use it? And is it open source? Yes, of course. Now the question, are there free security updates? And this is a question specifically for operations, how you run your production system. Are these updates free? Short answer, it depends. It depends which distribution you're using. So, well, most of you, as I just asked, are not paying for any support model. So that is always the question, and how should I say it? Not to play the devil's advocate, but to be fair, it actually makes sense to go on a somewhat support model if you use it in production and if you, well, use some features that are important to you, either features or the updates itself, that you get some support if you run important workloads. So you should somewhat consider that at least. Other than that, if you want to use free as in speech and free as in beer Java, what options do we have? And what support options do we have otherwise? So from Oracle, we have in the future, we get the Oracle OpenJDK builds, the ones with the GPL license. So this is still for free, and you're free to use that. And we will get updates, well, within the six-month release cadence. So that means once Java 11 is out there now, and within these 6 months, with the Java release update train model, we will get updates for this for free. You can use them, run your production system for that time frame. If you want to get security updates longer than that, well, you would need to pay some support model for that very version. Or you follow the cadence and say, okay, that was nice Java 11, now Java 12 is out, so we will use this instead and upgrade our production workload. That was the motivation, well, from the company to say, well, if you use it and if we should provide support, then companies need to pay for that. Well, if you use this OpenJDK builds, then you can use that for free, but this out of the box only includes that cadence. What else is there? That we have OpenJDK builds provided by Adopt OpenJDK initiatives and, well, also a lot of other companies. And then, well, nobody can kind of guarantee, but quite likely these companies and the community effort will also provide updates longer than the 6-month cadence, right? So if you use Java 11, then there might be updates longer than that, even in the free as in beer and free as in speech version, the open source version. Or another initiative that's also quite interesting is the Eclipse OpenJ9 model that is open source as well, and, well, is being updated and as well. Other than that, we have all major vendors that provide support options where you could, well, pay for Java that you run in production workloads. But that is basically what you should have a look at if you want to run Java for free. Also, in the very end, I will provide some links that basically explain the whole story a little bit longer. But that's just a topic that's quite important to me to say. Well, I don't want to spread some, I don't want the IT ecosystem to spread some fake news, because quite often decision makers and CTOs just, grab all this fake information and then make some decisions based on that, and then we have considerations to say, oh, should we move away from this technology, and so on and so forth. So that's a quite, well, somewhat important topic. Other than that, let's talk a little bit more about hardware, what we have in the cloud and somewhere else, and cloud-based, of course, scalability. And what I like very much about Java, that it runs on so many different environments and so many different hardware models. And, well, what we saw in the past, we have more and more and more hardware, and this Moore's law that, well, CPUs get faster and faster, and somewhat we, well, need to adapt to that. And of course, we also saw parallel computing in the past as well. What's quite interesting, a JVM, and this is pretty remarkable if you think about it. It can scale from the very smallest to the largest and biggest devices that we have. We have tiny computers, and we have humongous and huge computers. And you can use Java on literally all of them. So from the smallest integrated chips that we have Java on smart cards, we have Java on embedded devices, of course. You can run Java on a Raspberry Pi, to the very biggest. This is the IBM Z what I think is pretty remarkable, we have 170 PUs and 32 terabyte of RAM. I have not even 32 gigabyte on this laptop. I think I have 20, and that is terabyte of RAM. I mean, go figure. And you can run Java on that thing. That's pretty cool, I would say. And even more than that, well, we can scale from the biggest up to the clouds, where literally the sky is the limit. So if you run a cloud offering, then, well, you can scale until your credit card burns down and run your workload there. And of course, you can run Java there. So that's quite interesting. That's nice for Java. And it also offers or comes with some challenges for enterprise projects, because the model of that is a little bit changed compared to the past, right? If we had some on-premise hardware where we would run, well, our servers somewhere, maybe in our own data center or data center by some service provider, to a cloud offering, then what changes is that we get all of these resources and everything we need, all of that compute, literally on demand. So we can have compute on tap, can turn it off and on, and we can have literally everything as a service. If we need a database, if we need some platform, some Kubernetes cluster, if we need infrastructure, VMs, can all of that run just like this. Go to any random cloud provider and you can use these services. And then, of course, that's a question then, how do we adapt to our enterprise projects? How do we run a production workload? And what challenges does that bring to the Java ecosystem and to the language and technology? Right? So in terms of scalability, for example, new economics are behind that model, or what we need to think about, even more than the past. Not only is time money, but compute power is money and memory is money. So you can literally specify, hey, this application, run it with the -XMX, so and so much money. That, of course, corresponds to the compute size that you have, or whatever offering that you have, the size of the Kubernetes cluster, the size of the VM, or the memory of your on-demand workload, and so on and so forth. You put these new economics in place that you literally can scale that on demand and specify it. So that's quite interesting. What else is there? In the past, our workloads in production were more like a marathon, right? You start up your huge enterprise application, you start that humongous server, and then it should run for a long time, be available and up for a long time, and should run efficiently, right? So you typically have some monolithic applications that run for a longer time, and they should run with a high throughput. And you're totally willing to trade startup time or ramp-up time for a high throughput, right? We would not care if it takes 2 minutes to start up that thing, if then it runs efficiently, and if it maximizes the resources that we have on our server installation, on our premises, right? In a cloud, that might not necessarily be the case. Depends on which offering we use. So if you can ramp up and start up faster, then this becomes more like a sprint, right, rather than a marathon. Or it also can become like a sprint, or you even want to do both. You want to have capabilities where it starts up fast, and then also it should run nicely if you run it for a longer time. Your containers, your serverless solution, or whatever you have. And then, quite often, we have services that are short-lived. That might just be up for a few minutes, and that's it. And if they would already take a few minutes to start up, then, well, this would not be practical, right? So we quite often see also container-based solutions, microservices or not, where we fire up the services quite quickly. And then we have these challenges. So they should be more like a sprint, or they should also be capable of doing this sprint rather than just a marathon. So that is also a different demand, if you think about it, for the technology. So would an old WebSphere 6 be able to do that? Well, probably not, right? If we have deployment times from minutes and minutes and more. So that's quite challenging. If we think of scalability and the demand, you quite often have a demand that varies quite a bit, right? You have workloads, you maybe run some e-commerce system where during the day you have high demand and on weekends not, or quite the opposite. You have things like Black Fridays on your production workload. You have holidays like Christmas, and your demand typically varies a lot. So does it make sense to have a huge production workload that is capable to run, well, all that workload, including all the peaks, like this? How does your application respond to demand with one huge workload that covers all of it, including all the peaks, with maybe some headroom, because otherwise it wouldn't be safe to run all that workload? Or does it more make more sense to think of that and say, what about the red part over there? That's basically wasted money, right? If you have a single hardware server installation that you need to use anyway in your private on-premise data center, then this is a different story. But if we now fire up a quite expensive on-demand solution where you say literally of that resource that I'm using, most of it, or most of the time, I'm using not all of it, and I'm not using that efficiently. So, of course, the question is whether that makes sense with the new demand model, or if it even always made sense in the past. That's a question to spend all these resources. Or in other words, now that we have different capabilities, whether there's a better way to run this. So if we would split that up into smaller compute units, then we could scale them as we go, right? We just say, oh, that seems to be a period of high traffic. Let's just better scale it up to use more, whatever we have, VMs, containers, and so on, to be able to handle that traffic, and of course scale them down again as the traffic goes down, because that will save our credit card, and that is cheaper. So that just allows us to do that, because, well, in the past, how could we do this? Not really. If we run our environments on-premises, right? If we have an old server installation with our own hardware, how does scaling look like? Well, you literally go to your administrator, to operations, or whoever is responsible to it, as a developer or as a technical project manager, call them and say, hey, we need a new server installation for this project because it seems to scale up. And we know that Christmas is coming soon, so we need to be able to serve that bigger traffic, that higher demand, right? And then you get a response like, oh, yes, we can order a new service, a new server, and that might take a few weeks, and then we need to install it, and then we need to install whatever we run, Java, that old WebSphere, and our application, and so on and so forth. And after 4 weeks, if you're lucky, you get a response to the ticket, or you get a new server, and then you can scale up, right, with that delay. Would that work in this model? Probably not. So if you say, we need new traffic now, because now Christmas is coming, then you would either need to know that up front and say, okay, it takes so and so long to order a new server, a new hardware, and to install it, and do that during the summer. Or, what I just showed before, you use that model, where I just say, okay, we cannot react that with that agility. We just need to run all that workload all the time. So now, with cloud offerings and with compute and resources on demand, what we can do, we can ramp up all these workloads faster. How long does it take to start a new Docker container? Well, depends on what's running there, but milliseconds. So the smaller your units are, let's say this would be a comparison between VMs and containers, the better you can scale. So here we save even more workload because we are able to scale that how we need it by running smaller compute units. Again, this is only possible if our technology supports, for example, fast startup times and fast ramp-up time. That's quite interesting. The same is true if we look at the technology that's running. So ideally, we have a profile that looks something like this. Over time, we have a very quick ramp-up and startup phase for our memory and for the throughput we can offer for the application, and then that is just a flat curve afterwards, then we serve some traffic. But how the real data looks like, and this is now what I actually want to show you, so I even have a small demo for you, so not only boring slides. One real example of OpenJDK 9 in this case running Hotspot. So the typical JDK that you would run has, well, ramp up of the resource consumption more like this over time. So it takes a while to start that up, right? What we could compare that is there are new JVM runtimes upcoming, and because of these new challenges and new demands that we have in the cloud, we see more and more efforts being put into optimizations, specifically for startup and ramp-up phase. Who of you is familiar with Hotspot, by the way, or with the idea what it does? Oh, not everybody. So what Hotspot does in a nutshell, and this was a huge effort in the past, and this is one of the, well, greatest things we have in the JVM ecosystem, bless you. What it does, the runtime, well, basically runs your code, or in other words, it doesn't run your code, it interprets your bytecode, because bytecode, Java is portable. You write your Java and compile it into bytecode. And then, because that would be not that fast, what the Hotspot JVM does is that it compiles this while it is running into native code. So you will see the hotspots literally in your code. What are the hotspots? What are the method calls that are executed all over again, like thousands and millions of times while you run through your production code? And will compile that into native code on demand on your very machine. So that means in terms of that the Java still needs to be portable with your bytecode. It should, well, it is bytecode and interpreted, but you want to run native code on your very architecture to be able to run that faster. And this is what Hotspot does on the fly. It just runs your code, and over time it gets better and better and faster at running that. And then you will have, well, native performance, literally. And this is one reason why Java performs that well, although it is interpreted code, is because of this hotspot idea and the mechanics behind it. However, that takes a while. Fair enough. We just saw the marathon picture in the past. That was okay. You need some time to ramp up to really be warm and up and running, and then you can run this with a high throughput. What also we have now is some more direction, some more pace into a workload, into a runtime that can run, well, even with an even shorter ramp-up phase. So what is quite interesting, OpenJ9, this is what I want to show you today, is another alternative JVM that is, of course, also based on OpenJDK, but that has other optimizations on a runtime where you can even have a shorter ramp-up phase. OpenJDK with OpenJ9, and then, if you want to go even further, then we can have optimizations such as AOT. It's called ahead-of-time compilations. Hotspot is a JET, just-in-time compilation. AOT, ahead-of-time compilation. You compile that stuff into native optimized code or artifacts even before it is running. And then we can have things like class sharing, where you say, oh, I did run this very workload in the past on a similar machine, or I can even share my classes, the resources that are there in the JVM at runtime level with other JVMs, and then save even, well, a footprint of memory consumption. So all these movements are very, very interesting, and I encourage you to have a look at, well, alternative JVM solution. OpenJ9 is one thing. Another interesting approach is Graal VM by Oracle Labs. It has very similar ideas of, can we compile something ahead of time, and can we, for example, produce snapshots of ASTs, abstract syntax trees, that we can load up at startup, so we get a faster startup phase. So once our application starts up, I don't have to start to search for all the classes and see how the classes look like and wire them up and so on and so forth. I already know what's there because I ran my program in the past, and the classes are already preloaded. So ideas like that, and that's a very interesting approach specifically to, well, tackle these demands of the cloud, right? If we want to have fast startup, performance like Go or Node.js, startup performance, to say we want to start that up quickly because we want to run our Docker container now, not in 1 second, but now, then we need to somewhat tackle that and optimize on this. And I think this is a very interesting approach. So what I have for you is a very small demo, just a project that is totally credits not to me, but to my colleague Billy Corando. He's awesome. He built this the small little demo that runs well on actually two JVMs, on the OpenJDK with Hotspot and on OpenJ9. What I want to show you. So what we have here is I have two Docker files. Let me quickly show this to you. And this is a very simple approach. So what we have one base image that has the adopt OpenJDK base image. For OpenJDK with JDK 8, well, per random, that doesn't really matter, but that uses the default hotspot, what you typically have. And then what we add is, well, it's a Spring batch processor. That is a simple, a batch processing application that just calculates random stuff and throws them away afterwards, just like Bitcoin. And then we run this. Simply run this, Java minus Java -jar. You know, that's what you're used to. All right. The other thing is we run the same thing just with a different base image. The base image of Java with OpenJ9. So that's all. We use a different base image that uses the OpenJ9 distribution, and then run the same example. And of course we run them in parallel so we can see the difference actually in memory consumption. And that is a very small and first demo, just as an inspiration, what we can do if we optimize further our runtime. There is way more to OpenJ9. So for example, I could enhance this demo with AOT, what I just explained, and class sharing to say, I can run this once and then basically trace and scrape all these precompiled classes and then reuse them to have a faster startup time, or try to optimize it further for this very program and do the AOT compilation here. But just for you to see what we can already achieve by just swapping the JVM, the underlying runtime, to another one. Let's run this. And what I have here, what I do in my run in my demo, I literally run these two containers as Docker containers. Why Docker containers? Because it's simple to ship, right, and to build up. Rather than installing this all from scratch, I just run these Docker containers. And then we will have a small overview at the resource consumption of my Docker containers here. So what I do, I say run demos here, and then I have a Docker stats. The Docker stats is literally saying the Docker stats for the CPU percentage and the memory usage of these two Docker containers that will run. And that's it. So I start up these demos, and then you will see it. Oh, you can't see that. That runs the nice Spring logo here. And then what we have here is the resource consumption of these two containers. We run the hotspot and OpenJ9. And what you see, what is quite remarkable, is the difference in memory usage. So that we have 150 megabyte, and we have, well, this is a very extreme example here that typically is even lower. We have 800 megabyte, just the same program, same stuff, run in a different JDK. That's quite interesting. And also we see, well, some varying CPUs, so, well, that varies what they're computing right now. So many times the OpenJ9 is also a little bit lower. But just from the memory usage, you see that picture that I just showed you in the slides with the difference in memory consumption. So who is interested in that is that I will share the code for this very example with many more pointers for OpenJ9 specifically. What has been developed from my colleague, and then you can have a further look into that. So that was just a very small example. I hope you got the idea what you can do by just swapping a different JVM that is optimized for this. So that is specifically optimized for resource consumption. Yep. Yes.
Do you know if there are differences in the configuration of the garbage collector between the two selections that you did? So we have only seen you switch the base image, but I think this may include also some other defaults for the garbage collector.
No. A good question whether you change the defaults. So I didn't change the defaults. If you have a look at the command that I'm running, Docker file.
I'm not thinking about have you changed something.
Right.
I see that you just start Java.
Right.
I mean, does the different versions of JVM, do they already
Oh yeah.
some differences?
Yes. They definitely include differences, and that is how the JVM runs internally, and they might have different garbage collectors. That is actually one of the biggest, or how should I say it, motivations to run a different runtime, to say this scales better on our very specific demands, right? If you run applications that have a very huge memory demand, for example, then you might need a different garbage collector or tune it differently or configure it differently, and your runtime may already do that out of the box. So yes, there might be a different configuration. Other short answer, I don't know, and I don't want to know if that JVM does things differently internally, because that's a thing of the JVM. So ideally, and that's actually the nice story about that, is that you don't need to change anything in your configuration. I mean, you can always try to performance tune your JVM, but from experience, you can also do many, many things wrong if you don't really know what you're doing, right? So in terms of performance tuning specifically, and if you say, oh, I want to specify all the different sizes in my garbage collector with all this Eden space and heap space and things like that, from experience, that very often doesn't go that well. So ideally, your JVM runs things very well out of the box already, and then just by that, you usually shouldn't run into big memory problems if you run at a reasonable scale. Everything beyond that, then you definitely need some knowledge in performance tuning. But my point is, out of the box, you typically do not want to change, low-level performance tuning parameters here.
Did you also measure the real performance? I mean, we've seen that the memory footprint is smaller, but I mean, did you measure how many calculations the two containers?
Yes, not in this demo, unfortunately. My colleague did that, yes. And they were similar, and then some, well, that depends highly on the calculations, right? But in some things they were even faster. Or in other words, there are actually multiple demos where you would have multiple optimizations. So this is just the default, the very default, just run a different JVM. And then you can go further in that and say, okay, now activate this AOT compilation, activate class sharing, and so on and so forth, with a warm-up phase where you build your Docker container, you run it once just to warm up all the classes, and then you actually run in production. So you can do much, much more to it, yes. But in this very demo, what I want to show is that just by swapping the runtime, you can already achieve quite a bit. I mean, the same is true if you say you wrote a program in the past, right, like 10 years ago, and then you ran it with, what was there 10 years ago? Let's say, whatever, Java 6, Java 5, and now you run the very same thing with a modern Hotspot JVM, you would see a very similar outcome, right? A modern JVM, like from 8 to 9, there were a lot of performance improvements, and this is also one of the reasons why you should upgrade your Java once in a while, because then you actually get improvements, and things, move along. Same story with your car, right? Like a modern car, petrol engine has evolved a lot over the last 50 years, right? And electric cars will also. So, it's just a question how much engineering effort you put into things and what was the demand in the enterprise and in the workload that we had. So in the past, with this marathon demand that you say you want to optimize for a nice throughput over time after a ramp-up phase, that is a very good way to do so with the hotspot approach. But then if you have new demands, you might need to adapt. And this is one of the new things that we see more and more, to also optimize for faster startup and faster ramp-up phases. So that's what I wanted to show you with this. And I think that's a very interesting project that you might have a look at it. OpenJ9, just a few words on that. Originally came from IBM, and the slide obviously was not made by me. We believe, well, I just joined a month ago, so IBM believes that there's a lot of opportunity in moving that to an open source foundation. So originally developed by IBM, but now under the Eclipse Foundation, and well, an alternative way to run Java, or an alternative runtime, which is a very interesting solution. So we cannot do that on our own. We highly believe in open source software, so we should do that together. And of course, everybody can participate in that, just like in OpenJDK. And of course, it builds upon OpenJDK. And, well, it offers a very nice and interesting performance optimizations. Other than that, to the slides I showed earlier with the Java security updates. So this is also free to use, free as in beer and free as in speech. And there are also updates provided longer than 6 months. And there's a support option, of course, available if you want to run that in production. You can get one of these binaries either from an IBM download or here from Adopt OpenJDK. There are builds available that actually built on OpenJDK with Eclipse OpenJ9. And if you paid attention, that's actually what I was running in my Docker container, right? Adopt OpenJDK with this flavor, which is quite nice because then this builds your binaries, and you can grab that over there. Again, talking about Java, what else do you have? You can always build an OpenJDK or build a Java or an Eclipse OpenJ9 yourself. So the sources are available. It's free as an open source. You can just grab it and go with your own. But there are binaries available, and you can take them and just try it out. You just saw you can do and achieve quite a bit by just swapping the runtime. And since all of that is based on OpenJDK, it has to work, right? It's just Java, and you can run your production and just give that a try. See what your experiences are with that, and have a look at this. What else do we have with Java and Java in the cloud, and what else do we have with future improvements, future movements in our industry? So now a little bit about the future with specifically big data, data analytics, and even something like machine learning and AI. So this very much sounds like a hype topic, and arguably it is. But we all can be honest that this is somewhat the future, and that we all should at least have a look at it. Although humans are always somewhat reluctant to the future. But machine learning specifically and analysis of huge and big data is somewhat that we need to keep in mind, somewhat that we should become familiar with as developers, because we already see a lot of machine learning approaches that help improving IT. So I'm not talking about AI such as in the Terminator or even in self-driving cars, although they work pretty well. But approaches such as machine learning, where you can detect patterns in all kind of things in the daily life and then improve based on that. So when we came to performance tuning, just as a side note before, there are actually approaches that use machine learning to improve performance on runtime and on tuning of parameters, how to run your workload. Things like that. And then you get to solutions where we as humans would never end up if we use similar approaches. So just as an outlook, what other motivations and demands do we have in this field? So if we want to stay on top of things, and I say as in Java community, the JVM will need to offer somewhat reasonable machine learning and data analysis capabilities. And this is a field where the Java ecosystem definitely can do better as of today to, offer better solutions for the future, because that, is already there and will come more and more for the enterprises. There will be more and more machine learning solutions that we have. What else do we have for new hardware demands? GPUs, as in parallel computation as a high scale. Who of you mines cryptocurrencies or bitcoins? Hands up. Nobody dares to? Otherwise you would know what I'm talking about with GPUs. Yes, they run workloads in parallel at a totally different scale and also in a totally different way. So I'm totally not an expert on that, but a colleague of mine said the following: using a GPU without understanding how GPUs work is like driving your car in reverse all the time. Right? It's totally misusing our technology, or in this case, hardware, because you just use it. They work in a different way in terms of parallelism and how you run your workload, and we have to use them differently. And we somewhat have to, well, change our technology and change our applications, our code, how they run there as well. So there is an initiative by IBM with NVIDIA to improve, well, the performance not only of native code of C++ and what we always saw in computer games and things like that, but also with Java applications to, well, increase the performance specifically on OpenJDK with OpenJ9 to run this workload, a Java-powered workload there, well, at better scale on GPUs. So you can actually run Java on GPUs, and this gets better and better. And I believe this is, well, highly needed in the future. And I have to admit, I personally am usually on the back-end server side, and this is my world mostly, but still, that is something that the world is more and more moving to, so we at least have to keep that in mind and might have a glance on that if we want to stay on top of things in the future as well. But it's very interesting to see that we get some new Java APIs here, and the possibility to run that still in a Java ecosystem and JVMs. So that's an interesting thing. So you always, well, from now on, or probably that was always the case, you and your application will have to change as well. And this is something I just want to give you just as an inspiration, because it's the same story like with the Java updates, right? It doesn't help you to say, oh, now we have this application and we should never touch it again. Software always changes. There's a continuous change, and you can either fight that change and then suffer and have, well, efficiency that goes south, or you can try to stay on top of change, embrace change, use approaches such as continuous delivery, and try to, well, adapt and try to adapt to the changes in the world and changes in technology. GPUs, for example, require you to, well, think and act differently. The workload runs differently, and your code and the APIs. So luckily, we see changes within Java where that is supported here as well. And, well, you would have to adapt. And so is it true for AI and machine learning as well. So that's a thing we as developers, we as operations, and we as the Java community, if I can say that from my standpoint, should, well, do a little bit more. By the way, what does a server GPU, like a server-side GPU, look like? Again, some high numbers. A single GPU, not your small graphics card that you have, but a processing unit. The DGX2 has 2 petaflop, 512 gigabyte, and eats up 10 kilowatts. That's a huge thing. It actually weighs 160 kilo. That's as much as a fully grown Panda. Just imagine, you can Google for images. That is one GPU unit used for, well, in a cloud on a server-side setting. And we will see that more and more. If you ever have heard of Bitcoin mining or crypto mining farms, and in general GPU farms, these are server farms and huge data centers that consist of things like that, where you have huge GPU units that are used to do parallel computing. And, well, we might want to use that power. And we might need to use it in a way that our programs support it efficiently. And not only in a native way, such as assembler or C++, but with a language that we might be familiar with, such as Java. So the numbers of the GPUs are growing, and, well, luckily we have improvements there. Project Panama, for example, where we have better native code interoperability to make Java also more attractive for these new workloads, right? Not only embedded computing or cloud computing, what we typically always had with Java, but also GPU parallel processing. I think that's very, very interesting thing. And beyond that even, what else is there? What else will be in the future? Who knows what that is? Yep, just say it out loud. Yep, it's a quantum computer. So that's one built by IBM. How that looks, well, I'm definitely not an expert on that field. Actually, most of it is pretty boring. I heard that's mostly like cooling and try to stabilizing your actual QPU, I think it's called, quantum processing unit, which is tiny. So all of these shiny things just show around to make the quantum computer work. But that's also a very interesting field, and I'm quite proud that IBM does a lot in that field. And IBM Q, I think it's called, a quantum computer, that might also be of the future. So a nice story about that is that the JVM design and just allows us to, well, taking our code, the Java code, or any JVM language that you use, Groovy, Scala, whatever, to new places with a JVM runtime where you would have not expected before. So this write once, run anywhere mantra is still true. No matter if you look at tiny hardware, if you look at cloud computing and huge hardware demands, if you look at something like the future, what's not even there yet, we might be able to run our code and on environments that we could have not imagined. And this is, I believe, somewhat the beauty of the Java ecosystem and the biggest advantage that Java has. So with things like that, and specifically with the JVM, that's a very important thing to keep in mind. One of the biggest advantages of Java is the JVM ecosystem that we have. So one of my professors in college back then says a programming language is not really good or bad. It is what it is. But what it really makes it interesting are the libraries and the capabilities you can do with it, right? So if you think of it, Java has been around for 20 years, and there is code and libraries for almost anything that you can do, right? If you want to do video editing, there's probably an open source library for that. If you want to do zip archives or anything, you don't have to write that from scratch as if you would write your own programming language. There are things out there from which you can build upon. And I would add also what is one of the most important things for Java is the JVM runtime that we have. If we have things like Hotspot that we saw in the past, that we have this capability to run code that is actually just bytecode, just interpreted, but run it with native performance on whatever machines we have, or to run it with, well, optimization such as just-in-time compilation or garbage collection even, or AUT in the future things that we might see, that I can write code that runs, well, better and better in environments or in new environments. That is a huge opportunity, and that is, I believe, a huge power of the JVM ecosystem. So we could easily imagine running JVM languages, running new languages, Java, Groovy, or whatever, on new forms of processors, right? And that was the case in the last 20 years already. We can write a new JVM implementation, a new runtime that runs on whatever machine, your phone. Smartphones have not been there 20 years ago. But yet it is powered by Java, at least for Android. Yep.
One question.
Yes.
JVM on iOS.
There are. I'm not that familiar. There are definitely ways to run this in iOS. For example, Gluon. This company are able to run this on all mobile devices. I think it's based on JavaFX. And then runs with their. I think they have their own JVM runtime there. And then you can run apps on that even well. I would have a look at Gluon, Gluon. I'm not that familiar, to be honest, sorry. But I know that it is possible because this is what they're doing by writing their apps. So you can also run this on iOS. Yes, very true. And as a JVM, we can take this model and transform it to something new for some new hardware that might not even be there yet. So that is really the competition and collaboration of multiple vendors delivered to you to have these, well, all these efforts somewhat combined. If you think of OpenJDK with open source, if you think of Hotspot, or approaches like Eclipse OpenJ9, where that is open source, where that can be built upon if you have a new idea starting from there, for example, to run a JVM environment and a Java environment that runs your production workload, and that still will be there tomorrow and the day after by running on new environments. By doing so, we can have literally the fastest runtime environments available and optimize them and run them with native performance, even though we just have interpreted code. They can scale like crazy, these runtime environments. We have garbage collection functionalities and improve them more and more, and well, have compilers that also re-optimize them themselves. So for example, just-in-time compilers or ahead-of-time compilations, and we are still doing that, we as vendors, and of course we as a Java community. So I think that's a very interesting thing. Also, there are new JVM technologies, more and more. This is what I already covered. For example, new demands, containers that we have. So now we have container awareness within JVM. If you look at the memory usage, it knows that it runs in a container. We have more and more native code interoperability with things of GPUs. We can re-optimize just-in-time compilation and garbage collectors. AOT compilation does things like GRAL or OpenJ9, what I showed you. And more, we can run JIT just-in-time as a service for now. So if we have many microservice deployments, all of them run a hotspot, just-in-time compilation, right? And now there are approaches to say they don't have to run them all of them. We can offer that as a service, literally running on one server, and then they all just talk to them and see how they can optimize things to reduce the overall footprint. Also a very interesting solution. And you can put your idea here. If you're part of the Java community and want to improve things, if you run a very specific demand in your production workload in your company and you solve that in a very specific way, well, you're literally generating a new JVM technology and built upon all that knowledge of the last 20 years. So I believe that's a very interesting times and interesting ecosystem that we're in. And I'm personally very proud to be part of that JVM and Java community. And, well, I think we have somewhat a very interesting future ahead, and that's, well, a very nice time to be in. So that's all I have for now. Hope that was helpful. Thank you very much.